but let's have a look at our graphs. So today we're going to actually start drawing some graphs. And in grade 8, like, we don't really need to stress too much about the specifics of graphs and like all the nitty gritties of graphs. We just need to be able to draw them and see the relationship that we have. And so if you were with us for the first couple lessons, one of the things that I said is that one of the most important ways to represent relationships between variables is through either equations or graphs. And as we move up in maths, those will be the two sort of like focal methods that we use to represent relationships. And so what we're going to have a look today is using equations. So one of the important ways to represent a relationship, to draw a graph, which is another important way to represent a relationship. Now, in order for us to do that, as I've also said before, tables are quite helpful to us. So what we can see here is that I have given you an equation. So in question A, I have told you y is equal to x plus 1. So I'm telling you what the equation or what the rule is that we're going to use to describe the relationship. Now, we also know that we have got two variables that we need to consider. We have our input, which we know is our x value, and we have our output, which is our y value. Okay, now remember I said I sort of think of this like a number machine. I take the x value, I put it in, I do a whole bunch of different operations, and then I get an answer, which is my output. And so this is what the rule basically tells me to do. It tells me to take x, in this case, add 1, and then I get my output. And so in order for us to do this, we actually need some input values. Now, what's quite cool is if you want to go and draw a graph, or if you want to set up a table, you can actually pick any input values you want. As long as you apply the specific rule that you've been given, it doesn't actually matter what input values you choose. So I've got a table here, and I'm going to give us some input values. So I'm going to go -3, -1, 0, 1, and let's go 3. So those are my inputs. I've just chosen them at random, and you can always do that. You can always pick any x values, but as long as you apply the rule that I've given you correctly, it's fine. And we now want to get our output values. So I'm going to do the first one with you, and then I'll ask people to raise hands and give me some answers. If we look at our first output, what we want to do is we want to take the rule of y equals x plus 1, and we want to now take this value for my input of -3 and substitute it in. So y is equal to -3 plus 1. Now, guys, I'm using brackets to show that I'm substituting this value in. You don't have to use brackets, but it is quite useful to use brackets when we substitute, just in case there's like a multiplication or division we need to apply. In this case, it's not super important, but it is helpful to use brackets. Right, so now we go and solve this equation or simplify what we have on the right. -3 plus 1 is then -2. And so what I've got is that my output is -2. And so what this is saying is that when my input is -3, my output is -2. Okay, now we'll chat about what this actually means in a second, but let's fill in the rest of my outputs. So I'll give you guys a chance to do the working out here. I'll give everyone like a minute or so. As soon as you have an answer, and if you would like to try, you're welcome to raise your hand and give me an answer, or you're welcome to put it in the chat. But I'm going to give everyone a chance to work it out, and then we'll get some answers for our inputs and outputs. Okay, remember, all we need to do is substitute and make sure we apply our rule correctly.
We can do this, my kids.
Leo Bono, do you want to give us the output when the input is -1?
Yes, ma'am.
Okay, tell us.
The output will be 0, ma'am.
Excellent, well done. So guys, the output is 0 because -1 plus 1, 0. They essentially cancel each other out. Thank you, Leo Bono, well done.
Thank you, ma'am.
Okay, Amber, do you want to give us the next one?
It's 0, right?
Yeah, when the input is 0, what's the output?
It would be 1.
Excellent.
I calculate as y equals to 0 plus 1. It will give me y equals to 1.
Perfect, exactly. So guys, if x is 0, we're just adding 1 to 0, as Amber's told us. And so we get 1. Awesome. Right, Batabile, would you like to give us the output when the input is 1?
Yes, ma'am.
Yes.
The answer will be 2.
Excellent, because 1 plus 1 is 2. Fantastic, thank you. All righty. Right, so our last one. Our Kiwi, would you like to give us our last output here?
Yes, ma'am.
For everyone else.
What's your output?
Ma'am, the output is 4.
Excellent. 3 plus 1 is 4. Fantastic. Right. Now, guys, I know there's lots of hands. Don't stress. We're going to do lots more. So there'll be lots more chances for you to give me answers. Don't worry. Please also remember to mute yourself after you have answered.
Yes, please, because I cannot find you. Whoever is speaking at this moment. So please do mute yourself and then lower your hand after answering.
Please. Okay, guys. So what we've got here is essentially a whole bunch of values. Now that's cool, but we actually need to understand what these values are telling us. Now, if we have a look, I said that we are working with an input and an output, an X and a Y. And so what we need to remember is that when I've got an X and a Y pair, this should take me back to a coordinate, because remember, coordinates are X and Y pairs. And so that's exactly what I have here. I've got an X and I've got a Y. And so each of these pairs are coordinates. So if I list my coordinates, I've got a coordinate of -3, -2. I've got a coordinate of -1, 0, which is then my second coordinate pair. I've got a coordinate pair of 0, 1, 1, 2. And of course, I haven't left myself enough space. So let me just move this up. And a final pair of 3, 4. And so what this means is that I have got a set of X and Y coordinates that I can now plot on my set of axes. And that's what I have going on the right-hand side here. I've got a system of axes, or a set of axes, that I can now go and plot my points on. Now, just as a very, very quick recap, our two axes that we have are the y-axis, which is the vertical one, and the x-axis, which is the horizontal one. So when we plot our points, we need to do it in accordance to these axes. Now, your scale can be really whatever you want it to be. In this case, I'm just going to go up in ones. I don't really need to fill all of this in, but we'll do that. Okay, 1, 2, 3, 4, 5. I'm sure you guys can all see where I'm going with this. Remember, when you now go below the x-axis, you've got negatives. And when we go to the left of the y-axis, we also have negatives. So remember, this is like a number line almost. So we just need to remember where we've got negatives and where we've got positives. So that's my system of axes. And what I now am wanting to do essentially is take all of these coordinates over here and put them onto my set of axes. So what we can do is we can start plotting. So remember, it is always x first and then y. So if I go, oh, it would also help if I could do numbers properly here. -4, -5, right? So -3 is the x, -2 is the y. So I go to -3 on my x, I go down to -2 on my y, and I plot my point. Now, you don't have to do anything other than plot the point. I haven't asked for any labels just yet, but we can plot these points as we go. So the next one I've got is -1, 0. So that's on the x-axis. I then have the point 0, 1, which is now on the y-axis. I then have the point 1, 2, and the point 3, 4. And so what I've done is I've plotted all of these points. Now you don't have to do this. I'm just going to write the coordinates in so that you know exactly which point is which. I wouldn't write this down because it's going to get quite crowded. I'm just showing you which point is which point so that you know what it is that we're plotting and what it is that we're working with. So those are my 5 coordinates that I've plotted. And what I can see is if I now go and essentially draw a line joining all of these dots, I have got exactly that. I have got a straight line joining all of these dots. And so this is like one of the first and very important types of graphs that we work with, which are straight line graphs. Okay, so by plotting all of our points, we have been able to draw our first graph. Right, we'll chat more about this in a second, but I do see some hands. And Piwe, do you have a question?
No, ma'am.
Okay. Alrighty. So guys, what we can sort of see here, if we go back to our table, I can see that all along the X values, as I increase the X's, my Y's were also getting bigger. I went from a negative Y all the way up to a positive Y. So I was increasing my Y's. And if we now have a look at our graph, this is an increasing graph. It is increasing from left to right. And so my relationship between my X and my Y is an increasing one. And so my graph is an increasing graph. And this is how we can take relationships in the form of equations or number patterns or whatever the case is, and we can transfer it to a graph. Alrighty. So if you need to take your screenshot, and then we're going to give another one a try. Okay. Right, so let's move on to our next relationship that we have here. So our next
screenshots. Sorry.
Okay, so guys, our next relationship that we have here is y is equal to 3x minus 2. Now we're going to do exactly the same thing. We've got our inputs, which we know are our x's, and we've got our outputs, which we know are our y's. So again, I'm just going to pick some values for x. You can actually pick any values you want. I don't want to make them too big, so I'm going to go -2, -1, 0, 1, and 2. So I'm going to give you guys a second to try and work out your outputs. And when you've got some answers, you can go and raise your hand and I'll ask for some answers. Remember, what we want to do is like we did here, we want to substitute. Okay, I'm just going to quickly go back up here. You can still see the table, but just in case people need to see the graph or need to see whatever's going on here or take a screenshot, you can still see the table for question B, but everyone else, hopefully you can get what you need. Right, so remember, you're substituting. If you're using a calculator, that's absolutely fine. I have no issues with that. And your inputs are -2, -1, 0, 1, and 2. Okay, I'm going to give everyone another minute. And then I'm going to start taking some hands. ay.
We can do this, my peeps.
Alrighty. Let us see. Right, Lasejo, would you like to give us the first output when the input is -2?
I think it's -4.
Perfect. So guys, just that we can see with the first one how we would need to go about doing this. Y is equal to 3x minus 2. We would substitute in the x, the value of x, which is -2. 3 times -2 is -6. And so, oh, Lasejo, I don't know if I misheard you. Y is equal to -8 in this case. So -8 is our output. I can't remember if Lasejo said -4 or -8. But -8 is where we're at. Lungile, would you like to give us the second one?
Yes, ma'am.
Yes.
Ma'am, I'm not sure, but I think it's -1.
Okay, really close. Just remember when we go and substitute in, y is equal to 3 times -1 minus 2. Now 3 times -1 is a -3. So we've actually got -3 minus another 2, which gives me -5. Okay.
Okay, thanks.
Good. Well done. Alrighty. So our next one, -5. And Sandra, would you like to give us the output for the input of 0?
Hello, ma'am.
Hi.
Yes, ma'am. The output, ma'am, will be -2, ma'am.
Excellent. Well done. So guys,
Yes.
3 times 0 is 0, and 0 minus 2 is -2. Fantastic. I don't know what your name is. There's just some like broken heart emojis. You can let us know what your name is, and then you can answer the next one if you would like.
Hi, ma'am. Sorry, it's Winter. My brother was busy playing around with my tablet, so he changed the name.
No problem. What is your name? Sorry, I didn't hear.
Ma'am, it's Buntle.
Buntle. Okay.
Buntle. Okay,
Tell
got
me.
it.
Ma'am, the answer is 1.
Excellent. Well done. So 3 times
you.
1 is 3, minus 2 is 1. Fantastic. Lundeka, would you like to give us the last one?
Yes, ma'am.
Yes.
I think the answer is 4.
Fantastic. 3
Thank you,
times
ma'am.
2 is 6, minus 2 is
It's 4.
perfect. Well done.
Thank you.
Okay. So guys, once again, what we have here is our set of X and Y values. Again, don't stress all the hands. We do have more to do, so there will be more chances for you to give me answers. And I'm trying my absolute best not to ask the same people multiple times. So let's go and have a look at our coordinates here. So I'm just going to write them down. You don't have to. It's just sometimes helpful to have a list. We've got -2, -8, -8, -1, -5, 0, -2, 1, 1, and then 2, 4. So sometimes it's just helpful for me to write down my coordinates so that I can easily read off what it is I need to plot. Alrighty, so again, got my set of axes, and now I need to actually go and plot these points. I told myself last week that I need to do the numbers, and then I forgot to do the numbers. Right, so we put our numbers onto our X and our Y axis. Please do remember to label your X and Y axis. It's very important that we know which axis is which. We don't want to get confused and start using the wrong axes. -5. Okay, and once we've got our system of axes, we can actually start plotting our points. Now, guys, remember, it is always X first and then Y in our coordinates. So we need to make sure we do it as such. So our first coordinate is -2, -8. So we go to -2 on the X, -8 on the Y, which I clearly don't have. I need to just 6, 7, 8. There we go. So -2 on the X, -8 on the Y. And so I've got my first point there. Again, you don't need to fill in the labels. I'm just going to write them in so that you know which point is which, but you don't need to do that. Right, our next one is -1, -5. And so I keep plotting my points. And what we'll see here, hopefully again, is that once again, the relationship that I'm getting is a straight line. So when I eventually go and join all of these points, I'm once again going to have a straight line graph. Now you do get other types of graphs. We don't only deal with straight lines. They will be sort of the most important ones in grade 8 and grade 9. From grade 10, we start to deal with more types of graphs, and I'm going to show you 1 or 2 of them as we go along. But straight lines are very important. They're going to be with you from now until matric. So they are very important graphs to try and be comfortable with. Right, we draw little arrows on the end of our graphs just to show that this relationship can keep going. But we once again, like I say, have got a straight line over here. Okay, just quickly, sorry, I didn't see it on the chat, but I will explain now. To explain how 0 is -2, if we just go to that point on, or in the table rather, if I substitute in y is equal to 3 times 0 minus 2, 3 times 0 is 0, so 0 minus 2 is a -2. So through the multiplication, I actually get 0 as my product, and then it's 0 minus 2. Right, Sampiwe, do you have a question? Okay. Basvile, do you have a question?
Oh, sorry, ma'am. I didn't know that I raised my hand.
No problem. Okay, guys. So once again, take your screenshot if you need to. And then we're going to take a little brain break, and then we'll carry on with our graphs. Nompumelelo, I do see your hand. Do you have a question for us?
Yes, ma'am.
Yes.
I wanted to know if are we going to do the ma'am this what's this called? Ma'am, I'm still looking for this word. I'm not sure what it's called.
Okay, no problem. Put it in the chat when you find it, and then I can answer you.
Oh, here's it, ma'am. It's called
Okay, put it English. Pop it in the chat for me, and then I can have a look. Alrighty, guys. So last chance to take your screenshot, and then I'm going to move to our brain break.
Wow, time flies.
I know.
Screenshot my pebs.
Alrighty. Oh, sorry, everyone. All right, here is our brain break for the day. We're going to do it the same as we have been doing it. So I'm not going to say anything. We're not going to do anything. We're going to wait for the first person to come up with the answer on the chat. And then we're going to ask that person to give us the answer. Nompumelelo, I see your comment there. What we're doing now is essentially talking about the Cartesian plane because we're working with X and Y. We have done a section on like coordinate geometry and so on, and there's lessons on the website on that. So everything we're doing now does link to the Cartesian plane. The Cartesian plane is the X and the Y axis that we've been working with. Alrighty, guys, so here's your, sorry. Here's your brain break. We essentially want to know from you what the value of the final expression is. So the final expression is this one over here. What I need you to bear in mind is think about if there's two faces, one face, etc., etc. And like I say, we're going to wait for the first person to come up with an answer on the chats. Oh, golly. Okay, I just want to send you Linda the answer as well.
Yeah, so I was busy just responding to some private messages on the students. But yeah. Okay, let's go, my babes. Let's go. The final.
Sorry, Yolanda, I muted you. I'm very sorry. Didn't mean to
No,
mute you.
that's okay. At least I have the power to unmute. Let's go, my babe. Let's see who's our winner. Tepi, congratulations. Guys, Tepi got it. So, Tepi, if you would like, please raise your hand so that Teacher Sam can select you, and then you can tell us how did you get that answer, so you can explain to the whole class. Kwanda, yes, that's the correct answer. Anyone who got the correct answer, please raise your hand. It's not 1 or 8. Lisego, you got it correct.
I see Lisego's hand. Is Lisego going to explain it for us?
Yeah.
Awesome. Lisego, would you like to explain your step-by-step?
Yes, ma'am. For the first one, you say 9 times 3. It's gonna be 27.
Excellent. So each of these smiley faces are 9.
So for the second one, I said 8 plus 9 is gonna give me then 8 plus 9 is 8.
Which operation do we actually want to do first? I agree that it's 8, but should we be multiplying first or should we be adding first? Oh, yeah, sorry.
We multiply first, ma'am.
Good. So what is 9 times 8?
Ma'am, it's 72.
Perfect, which is why 72 plus 8 does give me 80. Excellent.
Yes, ma'am.
Okay, so these little winky faces here are 8s.
For the second one, I'm gonna say 8 plus 8, 8 times 5.
Good, well done. So 8 times 5 is
40, ma'am.
good. So 40 plus 8 does indeed give me 48.
Yes, ma'am.
Okay, now what do I need to be careful of in the last one?
There are 2 winky faces, ma'am, and 2
So what is that?
faces.
So the
It's
2
16.
faces that are winking, 16, good. And the 2 smiling faces?
It's 18, ma'am.
Fantastic. Okay, so now which operation do we do first?
We multiply first, ma'am.
Good. And what's 5 times 18?
5 times 18 is 19. 9.
Good. Good. And so what's 90 plus 16?
Then it's 106.
Well done. Fantastic, Lisego. Well done.
Thank you, ma'am.
Alrighty, guys. So that is indeed how we get our answer of 106. We need to be careful of our operations. We need to be careful of the fact that in the last one, there were 2 winking faces and 2 smiley faces. And remember, we always do multiplication first. Okay, it was slightly trickier because we had these, like in the second one, we had a winking face plus a smiley face times a winking face, and we had to work it out almost through a bit of like, I don't know, guesswork. But at the end of the day, we get 106 as our answer. Okay. Right, so any hands up, you can lower. We've got our answer. We are going to carry on with our graphs. So there will be more chances for you guys to give me some answers as we go along. Sorry. Yeah, my mouth is not going at the same pace as my brain today. I do see you wanting me go, see, I can't speak. I do see that you want me to go back to B, so I'm going to go back to B now. Right. Got the end. Okay, so here's B, just in case anyone didn't screenshot B, there it is for you. Alrighty, so let's have a look at question C. I've got some fun ones that I would like us to try, but let's have a look at this because this is a little bit different to what we've been working with. So once again, we've got our rule. Our rule's a little bit different here because now I can see that I've got a negative in front of my x. So I've got a negative 2x plus 1, but that's fine. We still have our input and our output. So once again, input is our x, our output is our y. I'm going to give you some inputs and outputs. Let's do a negative 2, a negative 1, 0, 2, and 3. Alrighty, so there are your inputs. Once again, I'd like you to find your outputs for me. You can raise your hand as soon as you have one. And then we're going to have a look at what our outputs are. I'm going to give everyone just a minute or two to give it a try, and then we'll have a look. Remember, you are substituting, and like I say, remember it is negative 2x. So make sure you are remembering that negative. You're also welcome to put your answers in the chat. Okay, I do see lots of hands. I'm just going to give everyone another minute. Okay, I'm losing names here. Yolisa, would you like to give us the first output? Yolisa, do you want to give it to us?
MM is 5.
Perfect, well done. So guys, I just want to show you this one because the negative can trip us up. Y is equal to, now remember we're substituting in negative 2 in place of x. So we've got negative 2 times negative 2 plus 1. We know that a negative times a negative is a positive. So this is actually positive 4 plus 1. And we therefore have y is positive 5. So that is why my output here is positive 5. Excellent. Right. Lufuno, would you like to give us a second one?
Yes, ma'am.
Okay.
Ma'am, the second one is negative 1.
Okay, so let's have a look here. If we substitute in, y is equal to negative 2. Oh, golly. Negative 2 times a negative 1 plus 1. Lufuno, what is a negative 2 times a negative 1? What are two negatives timed together?
Oh, ma'am, I got it wrong because I didn't see the negative then.
Okay, so what should it be?
Okay. Supposed to be negative 2, ma'am.
Should be 3 because negative 2 times negative 1 is a positive 2, and then positive 2 times 1 is 3. Do you agree?
Yes, ma'am.
Awesome, well done. Okay, so guys, remember, my words today. Please remember that there is that negative there. Okay, we don't want to trip up over that. Okay. Dimple, would you like to give us the third one? That's where we're at. Oh. Okay. Nokutula, would you like to give us the third one?
Yes, ma'am.
Okay, tell me.
Ma'am, I think is 1.
Excellent, well done. So guys, negative 2 times 0 is 0, and then 0 plus 1 is exactly 1. Fantastic, well done. Kagiso, would you like to give us the fourth one?
Ma'am,
Yes.
I think the first one is -3.
Excellent. Well done. -2 times +2 is -4, +1 is -3. Fantastic. Well done. Okay, Rorisang, would you like to give us the last one?
Yes, ma'am.
Yes.
It's -5.
Excellent. Well done. So -2 times 3 is -6, +1 is -5. Fantastic. Again, guys, there will be more chances to answer, so don't stress. We will get to more examples. Okay, so guys, we know that we have our coordinate pairs. We know that we can now go and plot this graph. And this is going to look a little bit different to our other ones, and we'll chat about why in a second now. So we need our numbers, and hopefully I'm actually going to remember to make my life easier next time, but that's fine. Remember, we always go X first and then Y. These numbers are going to go up in ones. I'm not going to write the numbers because otherwise I'm going to waste time. So our first coordinate is -2, 5. So I go to -2 on the X, I go to 5 on the Y, and I plot my point. My next point, and I'll just write it in for you guys so that you can see. My next point is -1, 3. So I plot my point. Next, I've got 0, 1, 2, -3. Oops. And my last coordinate that I need to plot then is 3, -5. Okay, so now we can go and join our dots. Again, we can see that it's going to create a straight line for us. And so joining my dots, I get this beautiful straight line graph. Now, what we can see is that unlike the second one, and I'm going to just zoom out a little bit here, we saw that the second graph was increasing from left to right. I can see that it's going up from left to right. But now this graph is going down from left to right. It's decreasing. But this makes sense because look, as X is increasing, my Y values are actually getting smaller. So as X is increasing, Y is actually decreasing. And so it makes sense that my line is decreasing here. Okay, so I'm going to zoom in again, just in case you would like to take a proper screenshot. Guys, we do need to draw it as a straight line, especially if it is a straight line graph. There are some graphs that don't require a straight line, and we'll look at hopefully at least one now. But if the points all form a straight line, we need to use a ruler and we need to draw it in with a straight line. Okay, so I'm going to give everyone a chance to screenshot if they need. Alrighty, let us have a look. What is our time here? Let's have a look at an interesting one. And this will sort of show you, we don't necessarily have to have a straight line, but our equations will look different and we'll see that the points don't form that like nice straight line. Amber, before I move on, do you have a question?
No, I don't have a question, but I just have something to say. You
Okay.
forgot to put a Y in output.
Ah, thank you. I also forgot to put my Y and my X. Thank you very much.
Problem.
Okay, guys, so let's have a look at an interesting one here. These are quite fun. So here, I've now got my fun equation of Y equals, oh gosh, that wasn't a fun highlighting experience. Y equals X squared. So nothing's going to change. I'm still going to substitute and I'm still going to get my output, but now I've got a squared. So things are going to look a little bit different here. So once again, output, which is X. No, it's not. Sure. input, which is X, and output, which is Y. Let's go 2, 1, 0, your -1. Okay, -2, -1, 0, 1, and 2. I'm just going to show you the first one so that we all know what we're doing. So if we take our input of -2, Londeka, I do see your hand. Let me just finish this and then I'll answer your question. Y is equal to X squared. So we've got Y is equal to -4 squared. Now, guys, remember what this is saying is -4 times -4. A negative times a negative is a positive, and 4 times 4 is 16. So this gives me a positive 16. Right, so I want you to try and get the rest of these outputs here. I'm going to answer Londeka's question, and then we'll take some outputs. Londeka?
Yes, ma'am. I wanted to ask, because you forgot to add the X and the Y by the graphs, do you always have to label it? Like,
Yes.
do we get a mark for that?
You don't always get a mark, but it is important to label it because we'd never want to mix up our axes, and this isn't really something you need to stress too much about now, but we can actually have more than 2 axes. So it is important that we label them.
Okay, thank you, ma'am.
Okay, cool. Right, so guys, remember we're substituting in the X in place of, or the X inputs that I've given you in place of X. In this case, a negative squared is a negative times a negative, which means that it is going to be positive. So just bear that in mind. Right, Simpiwe, do you want to give us the first one? The first one, I'm giving you the first one. Would you like to give us the second one? Simpiwe, I feel like I can hear you. Guys, Wangi's on it tonight. I'm clearly not on it. I hope some of these hands are up to tell me that I've substituted in the wrong value. It is not -4, it is -2. Who on earth knows what I was thinking? Negative, Thank you, Wangi. -2, so -2 times -2 is positive.
-4. Oh, positive 4.
Yeah. Miss Whitehorn has clearly lost her mind. Alrighty, let's try get some answers. So, Sabongo Kukle, do you want to give us the output when the input is -1?
Me? Can you hear me?
Yes?
Positive 1.
Okay.
Positive 1.
Y is equals to -1.
No,
Okay.
it's positive.
Number are we going to?
Right, so guys, this would be positive 1 because again, y is equal to x squared. So y is equal to -1 squared, which is actually -1 times -1. And 2 negatives multiplied together give me a positive. So positive 1.